I am Ankit. I work at Geekians, and from past couple of years, I have been building BlueStack. So, before jumping to the topic, I would like to talk about the essence of DX. So, what DX basically refers to? So, basically, DX is developer experience that developers will have while using tooling, libraries, frameworks, or anything. And there are a lot of factors involved that makes DX beautiful. So the first one is ecosystem. So ecosystem plays really important role in DX. So let's just take an example of Expo. So if you see, Expo has a really good DX from bootstrapping your project to developing the project and setting the CI/CD pipeline to deploy your app to production. So it's really beautiful. So having a good ecosystem is must. Then comes linting. Now linting helps you organize your code and make it consistent throughout your organization. And it involves a lot of factors. The first one is prettier, obviously. So your code would be prettified. Then comes variable naming conventions. So everyone can write variable naming at their own convenience, and that's not the correct thing. And you should maintain consistency throughout the organization. So linting is must. Then comes debugging tools. Now, debugging tools are really important. If you are not able to debug your code properly, or you don't have any debugging methods, then it becomes really difficult to debug the issues, and it may take your lot of time. And last but not least comes the TypeScript. So TypeScript gives you really good type suggestions, and it prevents the runtime errors, and you can predict your errors at static time. So for today's talk, we are mostly going to talk about TypeScript. So how I built a powerful typed system. So from past 1.5 years, I have been building CSS in GS library, and being a CSS in GS library, to have good TypeScript support is must. And if you don't have good TypeScript support, then there might be a possibilities that your users might not use your library. And being a CSS in GS library, it has a lot of features. It may have variants, themes, aliases, tokens, and things goes on. So to start off with, this is one really basic style function. So it takes two parameters. The first one is view, and the second one is, the first one is component, and the second one is theme. And if you see, we have here bg colon $primary. So bg is the alias, and $primary is the color token. And similarly for p is for the padding, and $2 is its corresponding spacing token. And that's not only. User can pass raw style props as well. So border color, border radius, or background color, the raw style prop. So to start off with, we will first type our component props. So basically what your component user passes. So we have here view. So first of all, the type of view should be inherited. So that is the first requirement. And then the another one is theme function. So inside the theme function, you should have type suggestions for raw style props. So to do that, it's basic. We can use generics. So generics are nothing but type parameters. So basically, it's parameters. So think of it as we have one function. it has one parameter, and that we can use that parameter. And similarly, TypeScript can also have that parameter, and you can use it in your function. So now the question is when to use these generics. So we have one example here, set color mode. Set color mode takes color mode as a prop, and it has, the color mode is going to be like static. It will have dark or light, and nothing is going to be generic here. So we can directly use the static types here. But we have another example here, create config. Now create config takes an object. That object has aliases, and that aliases has some shorthands. So, and the requirement is that whatever I pass inside that object, I should get it as a return type. So to do that, we can use generic. So basically, as you can see here, inside angle brackets, I have written t. So that t is type parameter, and I have used it inside the function parameter. So config colon t. And if you do this, you will get good type suggestions for the whole object inside there. Now, similarly, we will try to type our component props. So we have one style function that takes component, and it has a higher order component props, and it returns the component. So to type it, what we could have done is we can pass props, something like view props or text props or image props. But the problem here is, let's say I have a view component here, and view does not support color prop, and user may get suggestions for color, but it will be not supported. So it's incorrect. So to fix that, we can use generic here. So I have created one generic component that extends the React component type, so that user will not like pass any other parameter, any other type of component here. So I have assigned that component to here, and if you do this, you will get beautiful types inherited. Now the second part is theme. First requirement is that we want raw style props. So as here you can see, background color red, padding 16. So what we can do is we can create a type that will take type parameter, generic component, and we have one condition here. So basically, I am checking that if that component has a style prop. If it has style prop, then only I'll inherit it. Otherwise, I can type it like anything, whatever I want. I can type it any or whatever. So by doing this, we can get beautiful this style raw props. So all of the props are suggesting. Now the second part is utility types. Now there might be going to a lot of types that will be repeated throughout your code, and there are high possibilities that you will mess up your code. So TypeScript has default utility types for common transformation, and it includes record, omit, return type, read only, pick, and many more. And also you can define your custom utility types. Now remember earlier we had just suggestion for raw style props. Now we want that support for aliases and its corresponding token. So as here you can see, we have BG, $primary, P, $2. So how can we proceed with this? So we'll create one interface custom config that has aliases, and aliases has BG background color, P as like its original value padding, and some tokens, color token and spacing tokens. And we have one other thing, property map. Now what property map does is it has all original style props, background color padding, and its corresponding token scale. So what we'll here do is we'll map through the aliases and try to look up for its corresponding token scale. So we have here one mapped type that mapped through aliases, and you can, I'm checking if that alias original property exists in property map. So I'll just assign that particular token scale, otherwise I'll assign it as a never. Now, why assigning never? Because you may want to do some filtering, or maybe you want to remove that prop altogether. So that was about utility types, and here we are getting all aliases and tokens. And now, do you remember we had earlier logged our aliases and tokens? So we had created one interface, and that had aliases and token hard coded. And being a library, we don't want that. We want flexibility that user can extend that aliases, or user can define their tokens, custom tokens. So to do that, what we can use is modules. So modules is a feature that allows for modification or extension of existing modules. So for example, we have here declare module React Native, and I want to add class name to props of the text, because text does not have class name property in React Native. So you can do something like this, and this will extend the module. So similarly, we'll create one config alias. It has same aliases and token, but if you can see, I have written as const at the last. So what this does is this makes your object deeply read-only, and it indicates TypeScript that more information about the type, and it also infers the whole literal type as an object, and this is the benefit of it. So we have here imported that config. We have used type of operator to get config type, and we have declare module, and interface iCustomConfig extends the iConfig. So we'll do that. We'll get the typings of that. Now comes performance. We are not. We are still battling over runtime performance, and I'm talking about here TypeScript speed. But the question is, do we even need to care? Actually, it depends how complex your types are. Generally, it does not need, but we do have, like we have such complex types here. We will have variants, compound variants. We will have more functions, create global styles, create components, create styles. There are going to be a lot of components and types through and forth. So we'll really need to care about performance here. And there are going to be users that are going to shout at you, like, I am tired of restarting my TS server. So to diagnose with the performance, you can use the TSC diagnostic. Actually, we had, one user had reported issue related TypeScript memory overflow. So I have one demo. I can show you that. So to diagnose the performance, I will just simply do this diagnostic, and it will give me the stats of the TypeScript. It's taking a lot. Okay, so it has returned some diagnostics. The first one is files, how many files it has compiled, lines. The most interesting is instantiation and memories used. If you can see, memory is like 31 lakh, it's insane. So now the question is, how do I start debugging? So I'll do -" list file, and it will list all the files. These are all the files that TypeScript has compiled for you. But it doesn't contain any information like what file you actually need to look up for. So to do that, we have one cool CLI WebTree map. It gives you a visual representation of TypeScript bundle size. I mean, what file is taking what size. So this is here. And as you can see, 112 MB, it's insane. So you can go to your config and debug like what's happening here. So I'll go to config, I'll go to build and see what is happening here. So oh, its return type is, I think, manipulated. So it is returning whole theme and whole config as well. And this is insane, like it should not have been done. So you can debug it like this, and you can fix errors like this using TSC diagnostics. So yeah, that was all from my side, and thank you. We can.